Okay, see, dear students, this all questions from periodic classification of elements are very easy only. Mainly the all questions are related to periodic properties only. All questions are related to periodic properties only. Okay, let's see that. Third question, argon. Okay, argon, comma, potassium ion K plus, comma, calcium plus 2 they give. Okay, they contain same number of electrons, they only give. So what is the correct radius order they give? So how many electrons are present here, students? Argon has 18 electrons and potassium 19 minus 1. Because of positive charges increases, then the number of electrons will be decreases. So positive charge is present means the number of electrons. How to find out, dear students? Z minus charge. Z minus how much units positive charge is present, that value. 19 minus 1 is equals to 18 electrons. Calcium 20 minus 2 is equals to 18 electrons. Okay, see in the isoelectronic species, size or radius is directly proportional to negative charge and inversely proportional to positive charge. Okay, students. So based on that concept, the size order is for argon is more than and K plus and then Ca plus 2. So argon, potassium and calcium. Fourth option is correct. Okay, let's see that. Fourth question, which of the following order of the ionic radius correctly represented? Okay, see this H minus, H plus and H. One atom is having positive and negative charges. The negative charge is more size when compared to neutral atom and then positive charge. So the first option is wrong. The correct order is H minus is more than H and then H plus. Okay, students. Now the second option, C, Na plus F minus O minus 2 means Na plus is positive charge is lower size and compared to F minus and compared to O minus 2. The negative charge is increases, the size will be increases. The positive charge increases, size will be decreases. Let's see this O minus 2, F minus and Na plus. This is the correct order. Now this Al3 plus Mg plus 2 N minus 3. N minus 3 is more negative charge, that's why it is larger size. And compared to Mg plus 2 when compared to Al3 plus. Okay, so the correct answer is a third option. So this concept is also related to isoelectronic species concept only. Next, fifth question, identify the wrong statement among the following. Which statement is wrong statement? Let's see that. Third option, amongst the isoelectronic species, smaller the positive charge. Isoelectronic species, the positive charge is decreases, then the size will be increases. But here what they gave, smaller is the ionic radius they gave. Smaller is the ionic radius. Okay. Yes, Marani, understanding? So the wrong statement is third option, because in isoelectronic species, just now only we are discussed, the isoelectronic species, the positive charge increases, the size will be decreases. Positive charge decreases, size or radius will be increases. But here smaller the positive charge means less positive charge. Positive charge is decreasing, size should be also decreases, they said. That's why it is a wrong statement. Size, if positive charge increases, the size or radius will be increases. So the answer is a third statement is wrong statement. Okay, students. Now let's see the sixth question. Understood, ma? Yes, ma'am. Okay, let's go for next question, dear students. Sixth question important. This related ionization energy and electron affinity concept. Let's see how to remember this kind of questions, how to solve. For example, okay students, let's see the sixth question. For example, A only you have to take this A, loss of one electron is converted into A plus. This energy is known as a ionization energy. Okay, now this A plus, we are adding one electron is converted into A. It's released energy. It is a absorbed energy. Absorbed energy. And this is a released energy, electron affinity or electron gain enthalpy. Released energy. What we are doing, dear students, for example, listen carefully. On this mobile surface, this pen is present. Okay, I want to lift this pen. How much energy is required? That energy is absorbed energy. In the same way, I have to add. You imagine that this is the electron, this is the atom. So this is positive atom, means it is neutral. From neutral I removed one electron, then it converted into monopositive ion, and required energy is nothing but absorbed energy, maybe 100 kilojoules, you imagine that, or maybe 100 joules. In the same way, this monopositive ion, I have to add one electron. So the addition of electron is electron affinity or electron gain enthalpy. It is releasing process. How much energy will be released, dear students? In the same, one electron is added means 100 kilojoules per mole energy only will be released. One is absorbed energy, the second one is a released energy. So in that case, the ionization energy of A is equals to minus of electron affinity of A plus, electron affinity of A plus, because A is converted into A plus means it is the ionization energy of A. Then A plus is converted into A means electron affinity of A plus. Both are equal but opposite signs. One is absorbed energy, the second one is released energy. In the same way, sodium Na is converted into Na plus. Na is converted into Na plus. Its ionization energy. Ionization energy is equals to ionization energy of Na is equals to 5.1 electron volts. In the same way, the Na plus, we have to add one electron, is converted into sodium. Then the electron affinity of Na plus is equal to how much they are asked. So we know that ionization energy of Na is equals to minus of electron affinity of Na plus. Now we want electron affinity of Na plus. Already ionization of energy, how much they gave? 5.1 they gave. 5.1 is equals to minus of electron affinity of Na plus. Then is nothing but electron affinity of Na plus is equals to minus 5.1 electron volts. So the answer is a third option. Okay, students. One neutral atom is converted into monopositive ion. How much energy is required? The same way, one positive ion is converted into neutral atom. The released energy is also same. But one is absorbed energy. The second one is released energy. So this is very, very important. This related application, this kind of questions are very, very important. Compulsory they are asking in CET and NEET examination as well as JEE also. Okay, students, let's see the seventh question. Which of the following represents the correct order of the increasing electron gain enthalpy? Increasing electron gain enthalpy. Electron gain enthalpy is negative sign only because it is energy releasing process. What are the given elements, dear students? Oxygen and sulfur, both are in the same group, and fluorine and chlorine. This is second period elements. Already we know that we are discussed that electron affinity exceptions or some important applications related to electron affinity are important factors. In that factors we are studied the third period elements in every group. In every group, third period elements electron affinity is more than second period elements. Second period elements. Already we are discussed. Why the second period elements electron affinity is less? Is nothing but second period elements electron affinity is less when compared to third period elements. Means third period elements electron affinity is more than second period elements in every group. Means second period elements electron affinity or released energy is less when compared to third period elements. Due to the second period elements are small size, very small size, and high electron density is present around the nucleus in that group, and the repulsions will be increases, then the addition of electron is very difficult. That's why the second period elements has lower electron affinity values when compared to third period elements. That's why when compared to fluorine and chlorine, chlorine is more. Okay, chlorine is more, and compared to oxygen and sulfur, sulfur is more. Okay, sulfur to chlorine, if you are compared, both are in the same period, chlorine is more. When compared to oxygen and fluorine, fluorine is more. So what is the correct order, dear students? The electron affinity order, chlorine. Electron affinity order, chlorine is more than fluorine. Okay, chlorine is more than fluorine, and then sulfur, and then oxygen. This is the correct order. Chlorine, sulfur, and oxygen. Second option is correct. Okay. Now let's see the eighth question. The correct decreasing ionic radius of the following species. See this given K, Ca2 plus, K plus, S2 minus, Cl minus, all are isoelectronic species. Okay, Ca plus 2 and K plus, S minus 2 and Cl minus. If you observe that these all are having 20 electrons, sorry, 18 electrons, 20 minus 2, 18 electrons, 19 minus 1, 18 electrons, sulfur 16 plus 2, 18 electrons, fluorine 17 plus 1, 18 electrons are present. In the isoelectronic species, the size or radius will be increases with increasing the negative charge. That's why S minus 2 is larger size than Cl minus, and then K plus, and then Ca plus 2, and then Ca plus 2. Like option where it is present here, students, S minus 2, Cl minus, K plus. Third option is correct. Okay. Let's see that. Ninth question. Okay, students, ninth question. Among the elements calcium, magnesium, phosphorus, and chlorine, the correct increasing atomic radius or atomic size order we need to check. Okay, let's see the given elements. If you observe that beryllium, magnesium, calcium. So in that beryllium not present, but magnesium is present and calcium is present. All are in the same group. And nitrogen, phosphorus. Nitrogen and phosphorus they gave, and fluorine and chlorine they gave. If you observe that magnesium, phosphorus, and chlorine is belongs to third period. In a period left to right, atomic size or atomic radius decreases. So the atomic radius order, this is the correct atomic radius order. In a group size or radius, increases from top to bottom. The size or radius increases. That's why calcium plus 2, or sorry, calcium has a larger size than magnesium, and then phosphorus, and then chlorine. Okay. Last one, eighth question. Eighth question, what they gave Rani? S minus 2, Cl minus, K plus, and Ca plus 2. More negative charge is present, then it has more size. Because all are isoelectronic species. That's why S minus 2 is larger size than Cl minus, and then K plus, and then Ca plus 2. Okay. Now ninth question, the given elements are calcium, magnesium, phosphorus, and chlorine. Once you imagine that these all are S and P block elements. So magnesium and calcium are belongs to the same group. Calcium is belongs to the fourth group, fourth period, and magnesium is third period, and both belongs to second group. Okay, and phosphorus and chlorine, magnesium, phosphorus, and chlorine all are belongs to the same period, that is third period. So in a period left to right, the size will be decreases. Magnesium is more size or radius than phosphorus and then chlorine. Compared to magnesium and calcium, calcium is larger size. Okay, so the answer is calcium, magnesium, phosphorus, and chlorine. Second option is correct. Okay. Now 10th question, let's see. Among is that which electronic configuration, which one of them have the highest ionization energy? Highest ionization energy they are asked. So ionization energy in a period left to right increases, and a group top to bottom decreases, and if the atoms or ions have stable electronic configuration, it has more ionization energy. It has more ionization energy. Okay, students. Now let's see the neon 3s2 3p2. Neon 3s2 3p2 means third period. Third period, fourth A group element. Next, this neon 3s2 3p1. Third period, third A group element. Next, neon 3s2 3p3. This is also third period, fifth A group element. And it is 3s2 3p3. It is half filled. Stable electronic configuration. Okay, half filled and stable electronic configuration. If you observe that argon 3d10 4s2 4p3, outer shell is 4s2 4p3, it is 3s2 3p3. It is nothing but fourth period, third group, fourth period, fifth A group. So this is what are the given elements, dear student. The elements are present. Neon 3s2 8 plus to 10 12. S2 3p2 means 4 plus helium neon. Atomic number is 10. 10 plus 2 14. This is atomic number is 14. This is atomic number is 13. This atomic number is 3s2 3p 5 15. And it is argon 18 plus 10 28 33. This is 33. Okay, now this is phosphorus silicon, aluminum, silicon, phosphorus, arsenic they gave. So among that, which has more ionization energy, dear students? Phosphorus has more ionization energy. Fourth option is correct. Otherwise, without knowing the elements also, we can identify very easily. First option, third option, and fourth option all are in the same period. All are in the same period. And third option is third A group. First option is fourth A group. Fifth option is fifth A group. Means in a period left to right, the atomic left to right ionization energies increases, and also fourth option has stable electronic configuration. Means it has more ionization energy. Second option is fourth period. Period number increases, n value increases, the size will be increases, then the ionization energy will be decreases. That's why the correct answer is a fourth one. Let's see the 11th question. The correct size order. This is also size order they gave already. This question we are discussed. This is nothing but 8th question. Repeated this question, 8th question. S minus 2 is more size than Cl minus, and then K plus argon, and then calcium. First option is correct. Now 12th question, let's see. Which one of the following arrangement represents the correct order of electron gain enthalpy? Electron gain enthalpy. This question is also repeated, ma. This question is also 9th question. So chlorine is more than fluorine, and then sulfur, and then oxygen. So 12th question is second option. See 11th question. Yes, ma. First option not. S 2 minus and Cl minus, and then argon K plus. So third option is correct, dear students. 11th question. Means negative charge increases, then the size will be increases. Argon is neutral, and the neutral atoms are larger size when compared to positive ions. Okay, third option is correct, 11th question. 12th question is second option is correct. Cl has more electron gain enthalpy or electron affinity, and then fluorine, and then sulfur, and then oxygen. Okay. Yes, ma. Nishal, correct. Ishwari, correct. Third option, 11th question, answer is third one. Okay, students. Let's go for next question. 13th question. It's very easy. Which of the following arrangements represents the correct order of least electronegative, least negative to the most negative electron gain enthalpy? Electron gain enthalpy means it is energy releasing process. Means that more negative values present means more amount of energy will be released. So we have to identify that correct increasing electron gain enthalpy order of carbon. Okay, calcium. Calcium means beryllium, magnesium, calcium. Calcium, if you observe that N equals to 2, 3, fourth period element, calcium. Next, carbon they gave. Calcium, carbon we are identified. Okay, let's see the next one is aluminum. Boron and aluminum. Carbon they gave. Next, fluorine and oxygen. Nitrogen, oxygen, and fluorine. See, what I rounded up, those are the elements, given elements. These are the N equal to 2 second period elements. This is N equal to 3. This is N equal to 2. In a group, top to bottom, size will be increases, N values increases, size will be increases, then the electron gain enthalpy or electron affinity is decreases. That's why the correct order is like this. So the answer is fluorine is more than oxygen. Fluorine is more than oxygen, and then carbon, and then aluminum, and then calcium. First option is correct. Okay, students. Now 14th question, let's see the electronic configuration of the element. Outer shell is 4p2, 4s2, 4p2. Okay. What is the atomic number of the element with just below the above element they gave? Means this is nothing but the given electronic configuration is argon 3d10, 4s2, 4p2. We have to identify that next element. Which element that element is 5s2, 5p2 electronic configuration we have to identify. Means this is nothing but what is the group number, dear students? The group number is 4th A group elements. 4s2, 4p2 means 4 electrons present in the outermost shell. Carbon, silicon, germanium, tin, lead. Okay, this is n equal to 2, 3, 4. N equal to 4 means 4s to 4p2 means germanium. Next element is tin. The next element is tin. If you are observed that counted that electron, what is that argon 18? 18 plus 10, 28, 30, 32. See, germanium 32, 32 plus 18, 50. So the next element atomic number is 50. Third option is correct. That element is tin. That element is a tin. Okay, students. Let's see the 15th question. Which of the following is the largest size? Largest size means this is positive ion, it is dipositive, it is mononegative, it is dinegative. Which has more negative charge, it is a larger size. Negative charge increases, size will be increases. 16th question, the correct electronic configuration of inner transition elements. Inner transition elements electronic configuration, we know that n minus 2, F1 to 14 means inner transition elements means F block, ma dear students. F block. N minus 2, F1 to 14, n minus 1, D0 to 1, NS2. So like electronic configuration we have to observe. Let's see that. Like electronic configuration, where it is present here, students? Fourth option. Fourth option, let's see, NS2, N minus 1, D0 to 1, N minus 2, F1 to 14. So the 16th question answer is a fourth option. Okay. See, this fourth option is correct. Let's see 17th question. Which of the following is the smallest size? Smallest size means positive charge increases, size will be decreases. So among that Al3 plus has 3 units charge is present, F minus, Na plus and Mg plus, all are isoelectronic species only. All are having 10 electrons. All are isoelectronic species and all are having 10 electrons. So the answer is first option. Okay, let's see, let's go for next questions. 18th question, let's see which of the following is the correct order of the sizes of aluminum species. Aluminum only one atom having positive charge increases, then the size will be decreases. So the positive Al 2 plus Al plus Al Al plus Al plus 2. The positive charge of an atom increases, the size will be decreases. Means Al is larger size than Al plus and then Al plus 2. See, that is the first option is correct. Okay. Option B, not Basoras. First option is correct. Positive charge increases, the size will be decreases. Okay. So that Al is larger size than Al plus and then Al plus 2. Okay, Baswaraj, understood ma? Let's see that 19th question ma, dear students. Just it is a comparison only. So we know very well nitrogen and oxygen. Nitrogen and oxygen both are in the same period, but nitrogen has a 2s2 2p3. Electronic configuration is present, oxygen 2s2 2p4. Outer shell electronic configuration, that's why ionization energy of nitrogen is more, because the nitrogen has stable electronic configuration. So among the given options, nitrogen value must should be first option. First value is more than second value. First value is more than second value, like option where it is present. Students, see, observe that fourth option 11.32 and 8.29. This first value is more. This is related to nitrogen and this is related to oxygen values. No need to by heart, that just comparison only. Okay. Remember that whenever like this kind of questions, they are asked two elements among that which values are suitable. Means what is the relation between the two elements ionization potential, dear students? Nitrogen value must should be more than oxygen. Nitrogen is the first element, that's why first value is more we required. So regarding option is present in fourth option. Okay. Next 20th question, let's see the correct order of first ionization potential of elements. The given elements, if you are observed that beryllium, boron, carbon, nitrogen, oxygen. It's very clear, dear students. Beryllium has a 2s2 electronic configuration. Carbon has a 2s2 2p3 electronic configuration, stable electronic configuration. That's why the nitrogen value is more when compared to oxygen. Okay, it's very clear. Next, carbon will comes. Carbon. Next, beryllium will not comes. Boron will not comes. Beryllium will comes. Beryllium has larger ionization energy when compared to boron because of stable electronic configuration of beryllium and nitrogen. That's why the correct ionization energy order is boron is least when compared to beryllium, and then nitrogen is more when compared to oxygen. First option is correct. Just now only we have discussed that relation. So it is very, very important, and in concepts also we have discussed that ionization energies orders this everything. Okay, let's see 21 question. An atom electronic configuration they gave 1s2 2s2 2p6 3s2 3p6 3d3 4s2 3d3. The valence electrons are entering into the 3d3, means argon 3d3 4s2. So the how many valence electrons are present in n-1 and ns electrons? So the number of electrons in n-1d and ns is equal to 3 plus 2 is equal to 5 electrons. So the 5 electrons are present, means it is belongs to fifth B or fifth group. Fifth group means what it is, dear students? Scandium, titanium, vanadium. This is nothing but vanadium electronic configuration. Vanadium belongs to fifth group or fifth B group. So the answer is what is the group number they are asked?